Hi, it's Sammy again, and today what we're going to do, we're going to learn how to graph logarithmic functions. So first of all, I gave you one graph right here that I graphed for you already. I made these points very clear. So this is basically the parent graph, y equals log base 2x. So to be able to graph this, you should know how this graph looks like. So what's special about this graph? The first thing that you should know about this graph is the domain. So the domain is x is greater than 0. As you see, this graph here gets very close to the y-axis, but it never touches it. So that's why the domain is x is greater than or equal to 0. The range is y all real numbers, because this keeps on going forever down and keeps on going, as it is going very slow, but it will go up to positive infinity. So that's why the range is all real numbers. The next thing is, if you notice here, I made my points very clear so you could see them. So this is basically like a table of values, you know. But before we could talk about how this table of values work, it's the first rule that you should know, that log base a x equals b is the same as x equals a to the power of b. So basically, this raised to the power of this gives you this. Okay. So now, if you want to see how I did the table of values for this graph here, this is x, this is y. So just sub in the x values that I've used. So 1, 2, 4, 8. Now, if you sub in 1 for the x here and you want to solve for y, so basically it means 2 raised to the power of y should give you 1. And you know 2 raised to the power of 0 would give you 1. So that's how I got 0. And the next thing is, if I make y2, and the next thing, if I make x2 instead of 1, now 2 raised to the power of y should give you 2, so y is 1. And if I made x4, then 2 raised to the power of what gives you 4 is to the power of 2. And then if I made x8, then 2 raised to the power of 3 would give you 8, and that's why you get 3 for y. All right, and that's how these points came about. Now, you could also do a change of base and use different numbers, because here I was very choosy with my numbers. I chose numbers that I know when I go 2 raised to the power of what, it will give me these numbers right here. So let's say you didn't know how to do that, then you could just choose different numbers, but then you just do change of base. So change of base where the log base 2x. So what you do, you change it to y equals log x over log 2, because that's change of base. And then you could use your calculator to do a table of values. So let's say you didn't even choose these numbers. It shows other numbers, and you plug them into the x here. Let's say you chose 5 here. Then you just go log 5 divided by log 2. It will give you an answer. It will be a decimal answer, but that should be good enough. Make sure always to know your domain, you know, so you don't want to go, oh, I'm going to use -1 for x, because you know the domain here, x has to be greater than 0. Yeah, so now let's go to this question right here, which is y equals log base 2x minus 3 plus 1. So this, as we said, this is the parent graph right here. So if we compare this to this, the only thing that's different between this and this here is a translation. So we have this graph moved 3 to the right and up 1 compared to this. Yeah. So it's horizontal translation here, 3 to the right, and then up 1 here. So the first thing, when you know you move 3 to the right, you gotta move your vertical asymptote, which is this one, 3 to the right. So it's the y-axis. So you move it 1, 2, 3. And then what you do, you make your asymptote right here. All right, so this is your new asymptote. Now, the other thing you do, take each point, move it 3 to the right. So this 1, 2, 3 to the right and up 1. So it goes right there, And this point goes 1, 2, 3 to the right and up 1, so it goes right there. This point moves 1, 2, 3 to the right and up 1, and this point moves 1, 2, 3 to the right and up 1, and your graph now looks more like this. So now here, if you want to tell what the domain is, the domain for this graph is x is greater than 3. The range is y is all real numbers for logarithmic graphs. Let's say they ask you to find the x-intercept for this one. Okay, so let's say we want to find the x-intercept. So you know the x-intercept, you make y 0 to find the x-intercept. So if we make y 0, so we have 0 equals log base 2 x minus 3 plus 1. So now what we got to do, we got to move the 1 to the other side, so we get negative. So we get negative 1 equals log base 2 x minus 3. Now we got to go back to this right here, which is going from logarithmic form to exponential form. So the a here is the 2 and the b is the negative 1. So 2 raised to the power of negative 1 equals x minus 3. So x minus 3 equals 2 to the power of negative 1. And that's x minus 3 equals 1/2, because 2 to the negative 1 is the same as 1 over 2 to the 1. And therefore now we're just going to add the 3 to the other side. So we get x equals 3 plus 1/2, which is 3.5, and that's my x-intercept. And that's basically how you graph logarithmic functions. I hope this helped you understand this part of the logarithmic and exponential equations. Thanks for watching. Till next time. Bye-bye.